30 degree. First we have to mark the components, horizontal and vertical components for each forces, that is horizontal, vertical, horizontal, vertical, horizontal, vertical, horizontal, vertical, and see the directions. What are the direction? Left, right, up, down. Right positive, up positive, left negative, down negative. Those are the sign conventions we have to observe while solving the problem. One is the sign convention, and the second most important, the force which is making an angle with axis. If it is x axis, follow this. If it is the angle is with the y axis, follow this formula. It's very easy when you solve some more problems. Let us now work out with the vertical components. Sigma V. What are the sigma V for? As I told you, we are following this convention or this formula because theta is with the x axis. F1 sin theta 1, F2 sin theta 2, F3 sin theta 3, and F4 sin theta 4. What is F1? F1 is 160, sin theta 1 is sin 30 degree, F2 is 180, sin 45 degree, F3 is 80 Newton, sin theta 3 is 60 degree, F4 is 200, sin theta is 30 degree. Solving this, we get approximately 16.56 Newton. The unit of force is Newton. So we got sigma h is equal to 52.64 Newton, and sigma v, sum of the vertical components, 16.56 Newton. This is how we have to resolve the components, by taking care of the sign and the angle where it makes with the any of the vertical or horizontal axis. Now the aim of the problem, what we have to calculate here, as I told you earlier, we have to calculate the magnitude of resultant, as I have shown in the slide. R square is equal to sigma h square and sigma v square. As I told, for any resultant force you have h and v, and this is r, this is hypotenuse. We know the relation h square plus v square. The same thing we are following here. Here we have added all the horizontal components and added all the vertical components. The aim is to calculate the resultant force. So the formula clearly specifies to sum of the horizontal components, square of the horizontal component and square of the vertical components. So therefore R is equal to 52.64 the whole square plus 16.56 the whole square, then the resultant will be 55.18 Newton. This answer. And we also learned in the previous slides, sigma v equal to sigma v divided by sigma h. What is sigma v? 16.56, and sigma h is equal to 52.64, and tan theta is equal to 0.314, and here we are going to calculate the direction of the resultant. How will calculate the direction? That is theta is equal to tan inverse of 0.314, that is 17 degree 27 minutes 46 seconds. Resultant R we have to calculate, and direction theta we have to calculate. This can be represented in the coordinate system. Resultant R of 55.18 with an angle of theta equal to 17, 27, 46. Y-axis. Number of forces can be resolved horizontally and vertically. Any of the given problems, as I told you, remember the first point is in any of the coordinate system, remember sign convention. First one is a sign convention, and the direction is theta. Sign convention, positive, positive, negative and negative. First one, and the second one is angle making with, either it may be with x-axis or the resultant making an angle with y-axis. R1, theta 1, R2, theta 2, whatever it is. Always resolve the forces into horizontal and vertical, horizontal and vertical. Make sure that the theta is with which axis, and follow the sign convention to solve the resultant and the direction or the angle where the resultant is making with axis. So next class we try to solve some more problems where the sum of the forces acting with x-axis and the making it with the y-axis F1, F2, F3, F4. Here you can observe here theta 1, theta 2, theta 3, theta 4. Here the force F1 making an angle theta 1 with the x-axis, force F2 making an angle with the y-axis, and F3 with the theta 3 and F4 with the theta 4. You can observe both conditions. One is with the x-axis, one is with the y-axis. So these are the two things we have to observe, and next class we learn about we will solve some more problems to get the value of R and the direction. Thank you.